Hello chemistry students, here are your corrections for the homework on page 259, questions 29 through 32. Question number 29 says, what is a limiting reagent and excess reagent? Remember that your limiting reagent determines the amount of product or products if there are multiple products produced. You know that a limiting reagent is the limiting reagent because it's all used up in the reaction. And again, it's one of your reactants. Excess reagent then is the other of your reactants. It is left over after the reaction takes place. And it's not all used up. In the reaction. Your textbook answered it this way: the limiting reagent determines the amount of product possible from a reaction. Excess reagent is not used up by the reaction. Number 30, what is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with an excess of copper 2 sulfate? And they've given you the balanced chemical equation. So what is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with an excess of copper 2 sulfate? Again, remember they're telling you that because now you know that aluminum is your limiting reagent and your copper 2 sulfate is your excess. Now, what do they want the percent yield of? Well, again, they want the percent yield. Remember, our equation for percent yield is actual yield divided by theoretical yield times 100. You have to be given the actual yield. So they have to give you the amount of one of your products. So this 4.65 grams, this is the actual yield. Now, obviously, I need the theoretical yield of this. Remember, I'm going to calculate that. And I want the percent yield of this. That's what the problem is asking for. So, remember, to get the theoretical yield, we're going to calculate it. And we're going to take our limiting reagent, which is the 1.87 grams of aluminum, and figure out how many grams of copper we produce, and really that we could produce. That's our theoretical yield. So again, remember, our only way to change from one substance to another is a mole ratio. So 1.87 grams of aluminum. I'm going to use the molar mass of aluminum to convert it to moles of aluminum. I'm going to use then a mole ratio to take my moles of aluminum to my moles of copper. And then I'm going to use molar mass again to take my moles of copper back to my grams of copper, so that I can calculate my theoretical yield of copper. So again, the easiest numbers are probably my mole ratio, because that's my coefficients in my balanced equation. So my coefficient on copper is 3, and on aluminum it's 2. In my mole ratios, my coefficient in front of moles is always 1. My grams come from my periodic table, and I want to use 3 significant figures. So aluminum is 26.982. So I'm going to say it's 27.0. Again, here in this molar mass, it's a 1 for our moles of copper. And then again, copper is 63.546, so I'm going to use 63.5. I want to make sure I'm using at least 3 significant figures. On my calculator, that means I'm going to do parentheses 1.87 times 3 times the 63.5. I'm going to divide that by, I need to have parentheses 27 times 2. And I want 3 significant figures. I got 6.5969, so I'm going to call that 6.60 grams of copper that we produce. So now I can calculate my percent yield. My actual yield was the 4.65 grams of copper. My theoretical yield is 6.60 grams of copper multiplied by 100. So 4.65 divided by the 6.60, and I still want 3 significant figures. So I get 70.5% copper. So that is how you do that problem. Number 31. What is the difference between an actual yield and a theoretical yield? Which yield is larger for a given reaction? How are these values used to determine percent yield? So what's the difference between actual yield and theoretical? Remember, actual yield you get in the lab, or it's given in your problem. Okay. Oops, problem. Okay. Theoretical yield is something that you're going to calculate using your limiting reagent. Which yield is larger for a given reaction? The theoretical yield should be larger because it's the maximum amount you could produce. How are these values used to determine percent yield? Our equation is percent yield is actual yield over theoretical yield times 100. Your textbook answer for this one says the actual yield is an experimentally determined value. A theoretical yield is a value calculated using the balanced chemical equation. The theoretical yield is normally larger than the actual yield. The percent yield is a ratio of the actual yield over the theoretical yield expressed as a percentage. Number 32. How many grams of sulfur trioxide are produced when 20 grams of iron 2 sulfide reacts with 16 grams of oxygen according to this balanced equation? So how many grams of SO3 are produced when 20 grams of iron 2 sulfide reacts with 16 grams according to this balanced equation? Now, it's asking me for the amount of product, and it's given me the amount of reactants. Remember, anytime my problem gives me the amounts of both of my reactants, it's a limiting reagent problem. I first have to figure out which one's the limiting reagent, and then use my limiting reagent to calculate the amount of product. Remember, you have 2 options of how to do this. I'm just going to show you one way. Either way you do it, you still should end up with the same limiting reagent. So I'm going to choose to take, because again, as I've explained to you before, I just pretty much always start on the left. So I'm going to start with the 20 grams of iron 2 sulfide and calculate how many grams of oxygen I need. Remember that I'm going to compare that to what I have in my problem. So I start with my 20 grams of my iron sulfide. I'm going to use the molar mass of iron sulfide to convert it to moles, because remember, my only way to go from substance to substance is through a mole ratio. So then my moles of my iron sulfide are on the bottom. My moles of oxygen are going to be on the top. And then again, because my oxygen's given in grams, I need to convert my moles of oxygen to grams of oxygen. Again, easiest numbers are probably, right, my mole ratio, because those are my coefficients. My coefficient on oxygen is 15, and on iron sulfide it's 4. And then my molar masses, my moles are always 1, and the grams come from my periodic table and adding them up. So I have 1 iron at 55.845 plus 2 sulfurs at 32.065. So about 119.975 grams. And then for oxygen, I have 2 at 15.999. So that's 31.998. You just want to make sure you use at least 3 significant figures. So I'm going to take that, multiply it by my 15 times my 20. Divide that by my 119.975 times my 4. And again, I want 3 sig figs. So I got 20.0 grams of oxygen that I need. So remember, that means to react with all the iron sulfide, I need 20 grams of oxygen. I have 16 grams of oxygen. So I'm going to run out of oxygen. Therefore, oxygen is my limiting reagent. So again, I like to label that. So limiting reagent, that makes the other reactant my excess reagent. So now I can actually answer the question, which is how much grams of product. I have to start with my limiting reagent, which is my 16 grams of oxygen. Again, I'm going to use my molar mass of oxygen that I've already calculated once to convert that to moles of oxygen. I'm going to use my mole ratio to convert moles of oxygen to moles of sulfur trioxide this time. And then I'm going to use the molar mass of sulfur trioxide to convert moles of sulfur trioxide to grams of sulfur trioxide. So again, my easy numbers are my moles. So again, it's my coefficient. My coefficient is 8 on sulfur trioxide and 15 on oxygen. Again, in molar mass, it's always 1, and then I have to calculate this. So sulfur's 32.065, and there's just one of them. And there's 3 oxygens at 15.999 each, which gives me 80.062 grams. So I'm going to take that, multiply that by 8, multiply that by 16, divide that by the 31.998 times the 15 in parentheses, and I should have 3 significant figures. I got 21.35, so I'm going to call it 21.4 grams of sulfur trioxide that I produce. So again, that is how you do a limiting reagent problem. I hope that helps if you had some questions about your homework. Have a great day. I will talk to you tomorrow.